There's one on
What's it?
there.
Without adding it.
Let me just, I did put that thing up.
This one is.
I just got here though, so it doesn't matter.
But that's better than that. Well, like sometimes.
This mouse is delayed.
So like, I feel like that.
See, should I say? I'm gonna try to save this. If there's, copy paste.
You guys can understand.
I don't know. Do you know how to? Let's see. This is inside. I think this is in. Let's see. I guess we can just work through here.
You're like, what do you mean? 5D? No, because I don't have all my data.
Let's see. Let's see. That's gonna come down. All right. So. Save this.
Yeah, that's yeah. Like this week we've had.
Let's see. I'd like to save this to the desktop, but you know how to save it to the desktop if you're inside? It's inside. That's opened in Chrome though. I'd like to get it in Power not that. Oh, that. Yeah. Download.
Yeah,
that's what I didn't see. Right.
Yeah, it's kind of hidden somewhere.
Should I put it in
Yeah,
desktop? So where is downloads better?
yeah, documents would be, there should be a, why don't you do documents and see if there's a your name? You can just put anywhere.
I'm gonna put it on the desktop.
Oh, yeah.
We can throw it out there.
We can use it here too. You know, this is always
I think this might be better, right? Like you can.
go for it. But well, this way will the students see it?
Yeah, because I did share screen.
Oh.
Let's see, there's a way to do full screen here, right? Do you see the full, this? Yes, all right, that's good. We can hide these guys. All right, that should be good. I put these guys here. All right, so you guys, so Mingming Lu came down today from environmental, and I think one of you guys is a student in another class. I'm not sure who. No,
Environmental in there too? No?
there's no environmental.
Or chemical?
They're all chemical,
Oh, wow.
but they're eager to learn about biochar.
Oh, okay.
It's like,
So, are they seniors?
they're all seniors. So there's one, no, I think there's one or two that are junior.
There's a couple of
Fourth year, yeah,
Oh,
But-
wow.
yeah,
Wow. So you have a good crowd. Oh, wow.
yeah.
Oh,
So Mingming's been doing biochar since inception, I think, right? I found out biochar is 2005.
biodiesel 2005 and biochar maybe a few years later.
2015 or something, or,
Yeah, yeah.
okay, like 8 years or something.
Yeah.
All right,
Yeah,
So
now
maybe
I
from-
think about it.
is it from like when it started, or?
Oh,
I don't even know who started it, but I know there's a company in Massachusetts that my old advisor
Mhm.
for my PhD
Oh,
died, but before he died, he had given up working in science and he was doing biochar
oh, wow.
full time, and he was kind of like a promo man for
Wow.
biochar. Yeah,
Oh, there
somewhere in Mass, like Amherst, Mass, somewhere. So,
actually, there are a lot of New England biochar companies, and the most famous being is called Isaka Institute.
Oh,
That's where a lot of the biochar work is being
I
kind
see.
of published. So there's someone in Cornell called Jonathan. Yeah, I forgot his last name.
Oh.
He's really big
I
on
see.
on biochar. So a lot of New England biochar companies.
I see.
Yeah, I wouldn't be surprised.
Yeah,
Yeah,
anyway, he's
better.
pretty psyched about it. It's kind of funny to,
Oh,
anyway, so I know you're doing it, so it's kind of weird, but
oh,
anyway, yeah,
so what kind of feedstock he uses?
I think they're using agricultural stuff,
Oh, okay.
yeah.
Wow.
There's also recently, like you were doing stuff with the insects, right? Insects
Well,
for biochar.
They wanted to do that, but they haven't given me any samples.
Well, there was an article in Washington Post, the whole thing about insect farms, growing
okay.
insects for kind of biochars and animal feed.
Oh,
But
okay.
yeah, so I guess that's a big deal now. I,
Oh.
you know, so
Oh, wow.
at least, yeah, I think it's in France or somewhere in Europe, but. So anyway, there's a lot of aspects to biochar, different angles, but
Cool.
anyway, you want to just
Okay.
go ahead and, yeah.
Okay.
So,
Yeah, let's get started. Thank you, Greg. I think this is a great opportunity. So let me see a show of hands. How many of you have dealt with activated carbon before? No, you chemical engineers, seriously? In your co-op?
we're gonna do a tour.
A little bit like carbon beds, like collecting the VOCs that were coming from,
Wastewater treatment.
it was coming from like air treatment areas, so. I was looking at that.
So they kind of use it to absorb odors. So I would think the chemical engineer deal with active carbon daily, because that's a pretty much beloved compound for chemical and environmental engineering with respect to pollutant control. You know, they use active carbon for everything. Like actually, it started as the gas mask. In the gas mask to prevent the soldiers from breathing in the toxic air. And then activated carbon really took off. So what do they do in Africa when they burn the biomass? They make activated carbon out of it?
They make charcoal and they burn the fields and till it in sometimes. I don't know. I mean, the universities are doing biochar.
Oh.
I'm not sure about basically the farmers just burn the fields and till it.
Oh.
And I know that I talked to the Nigerian students, grad students about this, and they said that they don't do any biochar, but everybody burns their fields.
Oh.
In Ethiopia, actually, I've never seen them really burn fields in Ethiopia.
Oh.
I think they just till over waste into the soil.
Well, you know, from now on, with the active carbon, so they are not actually mysterious or anything. We do see a lot of home use of active carbon as well. Think about it. What do you use for your home? Yeah, Rita does say it has active carbon. So water filtration. How about your fish tank? You guys have fish tanks? Okay, maybe not, yeah. So the fish tank, of course, uses much cheaper active carbon. And, you know, that there are a lot of other, anything filtration related. And if you want the filtration to have a higher efficiency or filtering some more challenging compounds, you use active carbon. So today we're going to talk about biochar. Think about it as the cousin of activated carbon. And the biochar, coal, they are also kind of related. There's a lot of similarity going through the process of making them. But you know, we just control the condition a little differently. That's how they make biochar. And carbon negative. So how many of you have worked in the carbon sequestration type of work before? like your co-op, your research, several of your professors are doing carbon sequestration. Okay, well, so essentially we are facing the challenge of too much global warming, and we want to control the carbon. We want to reduce the carbon if possible. So biochar is being regarded as one of the technologies that can do that. So we call it carbon negative. And if you burn coal, that's carbon positive, you're generating CO2. But if you use biochar, that's carbon negative. And of course, that's a nature-based solution. That means a lot of the nature-based things, they work with how nature works, and they are more sustainable, more environmentally friendly in general. So that's what we think of biochar. You guys must have seen this or something like this. So this is the big picture of why we're considering the carbon balance. We are essentially having this greenhouse gas layer if we are burning carbon containing fuels. We're burning coal, burning natural gas, burning oil. Then we add greenhouse gas, it adds to global warming. So that's about the greenhouse gas effect. And then there are a lot of publications with regard to the carbon negativeness of biochar. And I'll just put it in here. You can read it on your own. And this is, published in Nature. So we say this is kind of has some sort of authority. So let's quickly look at the last paragraph. Based on European emissions of about 1.1 gigatons of carbon per year, we estimate biochar would offset around 9% of your emissions. So that gives you a kind of some quick indication of what biochar can do. And so biochar is, first we'll go through what is biochar, and then there are many uses of biochar as soil amendment. So the first use of biochar by the native people is used for soil amendment. And then there are some other extended uses that nowadays draws to biochar's similarity to activated carbon. So we use it for pollution prevention, for all kinds of applications. And then, of course, the construction people are interested in putting biochar into concrete or into asphalt to replace fly ash in there or to make it more carbon neutral. So, and even people feed cows biochar so that it can sequester the methane emissions from cows. So there are many, many different uses of biochar. And the biochar do look like this. I rushed out so quickly today. I should have brought you guys some little packets of biochar that we make. So this is one of the historic records of biochar that in the Amazon jungle, those people, they started to practice using biochar to enhance soil fertility. So the left side is a nutrient-poor Amazon soil. And then the right side is the biochar enhanced soil. And of course, the biochar enhanced soil helps with plant growth. So that's one of the earlier documentation.
That's like a meter?
I don't really know. Maybe that's a good point. They shouldn't dig out that deep because it's like 4 inches of
Oh,
the growth region. I would think
okay.
that's
pretty deep.
so. If you look at the biochar from a microscope, you do see biochar supposed to have many pores, and it's defined as a powder-like material, carbon material, thermally produced without with low or no oxygen. So that's pyrolysis. You guys have learned pyrolysis, right? Combustion. Good. That's good. So you know, after some training, you'll be able to make biochar. Right. And so the biochar used in soil, this is the justification. So for the chemical, you know, fertilizer enhanced the plants, they eventually they are not rich in the microbe communities. So biochar helps to grow the microbial content in the soil, makes it more porous, and makes it better to retain water and retain nutrients, which is very important. So retaining water means you don't have to water the plant that much. So why we want, you know, in addition to keeping the nutrient keeping nutrients in the soil is good. So in addition to it's good for the plants, why is it important to keep the nitrogen and the phosphorus, especially the nitrogen and phosphorus, in the soil without washing out? So is there a reason we should do that? Yeah. That's good. So fertilizer runoff, they will cause eutrophication, algae blooms, and you know, we heard of algae blooms are pretty close to us, right? So where did you hear the algae blooms? In Ohio, or somewhere else?
Michigan, Toledo area.
Toledo Lake area is kind of shallower in the Toledo area. So there's a lot of algae bloom, and it's kind of deeper in the other side, like Cleveland. So they don't have as bad. And if you see a lot of the water areas, ponds, they turn very green in the summer, right? With all the algae floating in there. That's kind of an algae bloom that we see. We don't have to go to Lake Erie to see it. It's right there in a lot of the neighborhoods, right? So you know, keeping the fertilizer within the soil, that's very important. So we don't have.
Woods has a huge algae bloom. The whole thing is green.
Yeah, I would think so.
It's a huge mess.
Oh wow. And you're right, in a lot of the urban waterways that they have a lot, even the retention ponds, they do, you know. So this is we've kind of touched upon this before. The biochar can help with water retention, with nutrient retention, with hosting microbial community, and then it can also, biochar is made with carbon, so with the renewable carbon. So it has it's itself fix the carbon that way. And then it can also absorb some CO2 from the air. So that's how it's called carbon negative, right? And so there are some further explanation of biochar's help. So essentially, it's talking about the same thing. It helps with the plant root system and help to, so those numbers are the numbers of biochar contribution to carbon fixing. So scientists say this biochar use would stash 8.6 gigatons of carbon dioxide in the soils. And then that's larger than what the US produces. And then the next one say, changing agricultural practices also helps. So
seed capture, but it doesn't, I mean, eventually it gets released again, isn't that so what's the life cycle?
so it captures CO2, so plants can use some of the CO2. So it needs, well, there's a lot of needs in studying how much CO2 is actually trapped. So a lot of this has been quantitative so far. And, given the large scale, we have a pretty much open system. It's studying it's kind of challenging.
There's a company now that's pushing the idea of not burning, but just packaging, compressing into bricks, the agricultural waste.
Oh.
Taking the bricks and burying the bricks. So I don't know, that's probably competing with biochar, I guess, right?
Yes or no, oh, wow.
Yeah, I just read an article about this. They're pushing it like this is the solution to like making these dense bricks, compressing by pressure.
Oh,
and
okay.
just burying those things. But
wow.
not, I guess there's no agricultural benefit to it. It's just a disposal of
well, if they can make money, if someone's,
they're trying to do.
Yeah.
It's a company.
If someone sponsors them, yeah, go for it, right? Yeah. So this is of course the carbon cycle. If we don't do much, we don't have biochar with it, the CO2 would be fixed and then be released again, especially when we have a lot of the carbon burning operations, factories, it will be released back again. And so this one without biochar would be something like this. We do see the carbon is recirculating. And with biochar itself is carbon. So we put it in the ground and the biochar can absorb some carbon. So biochar essentially would intercept some of those CO2 and eventually be good for us. But biochar does have a smaller contribution, 9% of carbon sequestration for Europe. And also it takes a while. So, nature does good things, but nature-based solutions always take time. And if we're impatient, then you can't do anything about it. And then how's the biochar made? Biochar is made pretty simple, actually. They're pretty straightforward. So we make biochar in the lab. We can use a furnace. We just supply carrier gas other than air, and then we heat it up. We make biochar. And then this is it's actually a commercial biochar furnace. So it has two layers of the furnace inside, and then the inner layer is pyrolysis, the outer layer is combustion, and then they draw air this way to minimize smoke. So that's a kind of a commercial biochar system. They do sell this system and make money out of it. And then, people can certainly make it themselves if they're very hands-on. So the feedstocks, yeah.
So I would agree with you. We use something that seems very similar called carbon black, and so we're using biochar pretty much the same thing as carbon black, just a different name, or are they slightly different?
They are carbon black, kind of would be closer to activated carbon.
Okay.
I would think they are made with is likely to be higher temperature than this. The biochar temperature range, there's still a lot of organic compounds, but carbon black is kind of more of coal type of material.
Carbon black, they use it like acetylene. So you burn acetylene, something like a furnace, or you have like a rocket engine. You shoot acetylene through it.
Yeah, they can think. can really control the.
Yeah, you control the temperature, the particle size, and the surfaces, like you'll have a graphite surface and things it's tuned. So it's gonna be a lot more money than biochar. Biochar is like free.
Yeah.
Biochar is kind of dirt, dirt cost, agricultural waste. That's an engineered material. It's like silica, carbon black. They're all carbon. I mean, in the homework, I put a list of all of the carbons, including diamond. Basically,
Yeah, actually.
diamond's different, but basically this probably 20 kinds of carbon, different things. It's a good question. It's really good because there's coke too to make steel, right? So
Yeah.
there's coal-derived carbons and there's gas-derived carbons. And this is agriculture, like charcoal, biochar, and then maybe some activated carbon. Those are in the families, right? I think.
Wow.
Right?
Yeah.
Isn't that true? Like activated carbon, charcoal, and biochar. They're closely related.
Actually, they are.
Yeah.
Activated carbon,
And they
a lot of it.
coke and coal. So petroleum coke to make graphene, synthetic graphene, and you can dig up graphene out of the ground too, which is also carbon. They're all different, you know. So graphene you're going to use for sheet graphene you're going to use for lithium ion anodes, but you couldn't use biochar. It's like they're all like different. Then you have buckyballs, graphite for anodes, and then graphene from graphite, or you can synthesize graphene from chemical vapor deposition. It's probably important to know roughly all those carbons, like they're all the same thing chemically, but
Yeah, they are made a little differently, and they have the post-processing a little differently, and of course feedstock and.
well, you have no crystallinity, right? I mean, there was graphite
This
is
one.
going to be crystal. There's crystalline sheets. Diamond is a diamond cubic crystal.
Oh, this one wouldn't. It's kind of.
Carbon black can be amorphous and crystalline. So the surface, if you have conductive black, it's going to have a graphitized surface that conducts electricity. So you use that. You don't use that in tires because the surface isn't good for bonding. It's a pretty good question. I mean, there's a lot of carbons.
Yeah, and price range is very
Price range is
different.
very wide,
It's
yeah.
huge,
So
right?
this is the bottom
Yeah.
end. I mean,
Yeah,
maybe cheaper than charcoal, right?
it should.
Because charcoal is kind of like an upscale biochar. I think.
Yeah, that's true. Yeah.
They don't bury charcoal for agriculture.
So if you see the list, you know, there's a wide range of things. Certainly agricultural waste is there. And if you see the list, pretty much they are all kind of residuals, all from waste origin. So one of the attractiveness of biochar is biochar can be made from waste. That reduces its cost quite a bit. Most of the times the feedstock cost, they are more than 50% of your production cost. So if we can reduce feedstock cost, that's good. That's one thing people want to consider, right? And then we've made spent coffee ground biochar mainly in my lab. So before I made spent coffee ground biochar, I actually tried to extract biodiesel out of spent coffee ground. You guys coffee drinkers? Yes or no? Okay, so what do you know about the coffee grounds? You know, does it contain oil? Yes, no. So do you see the oil from when you drink the coffee? You sometimes see it? Oh, so like what time? What kind? When do you?
Sometimes we like should oil on coffee.
Oh, okay, yeah. See, is that the real dark black, you know, kind of processed coffee or just regular?
Just plain.
Okay. So think about it. Coffee beans, fruits, they have about 8 to 20% oil content, like every kind of fruit, it has some oil in it, right? So we, in the traditional biodiesel producing, you extract the oil with organic solvents such as hexane, and then make it into biodiesel. So we pretty much developed a process that removes the oil and make biodiesel in the same step. And then we were so excited, we're going to tell the world we're making biodiesel. And that's only the 20% of spent coffee ground. So for the 80%, we haven't done anything with it yet. And then, so we got that, and
So
then
what's sulfuric acid do?
it's removing oil, so it's a making biodiesel process. We use it as a catalyst to make biodiesel. And then, we started to, students love this idea. We have some students, they did the REU, RET type of work. And then we applied for a grant to do market discovery. So like, what are you going to do? Is there any company interested in you? And then we started to talk to different stakeholders, that most of them non-researchers, not college professors or anything, just anyone other than college professors. And then we found out, what are you going to do with the rest of the 80%? We need that as well. So at that time, we pivoted to making biochar. And then
Couldn't you use like supercritical CO2 to do that extraction? Maybe better. Is the oil flavored like super coffee flavor or something? Or I wonder if it's got like, you could use it like that.
A good question. If you don't want the caffeine to be in there, you have to wash it a few times when you get the spent coffee ground, so that the caffeine is washed out. It's water soluble.
Oh.
So well, if we see this again, your professor asked about the sulfuric acid. So we added that for oil extraction, but when we make biochar, we found we made an acidic biochar. So all the biochars in the world, they are alkaline. We made an acidic biochar. And then what are we going to do with it? Where do we find the market of that biochar? You guys grow things in the garden? So someone have hobbies of growing things? You do? What kind of things you grow?
A lot of fruits and tomatoes, peppers, herbs.
Okay. So what about the soil condition? Do you worry about the pH of the soil for your produce?
Not usually. We also have chickens. But those types of
Chicken manure. So how about strawberries, blueberries, anything, any of those type of soil, those things prefer, you think? You guys put put spent coffee grounds on tomatoes, tomato fields? Don't know that. So a lot of the times people put raw spent coffee ground to their tomato plants because tomatoes love acids, and turn out strawberries and blueberries and quite a few veggies, they do love acidic conditions. So we found out from the customer discovery that our acidic biochar could be more useful for the urban farming applications. Like in the urban farms, they grow fruits and the vegetables. They won't grow corn or soybean or tomatoes, and those things they don't make money. But the more expensive kind of veggies and fruits, they do make money. So we do find some applications of acidic biochar as well as alkaline biochar. And well, of course, if you are interested in reading this spent coffee ground and biodiesel, you can read it. And then we found that there are more use in the biochar than the biodiesel, and then the whole research switched to the biochar part. And of course, the biochar, they are used as soil amendment, and acidic biochar do have some potential in urban farming. And what about the green roofs and the green walls, right? Those places we put like the green walls, you cannot put a lot of soils in there, right? So what if you have some biochar in it? It helps retain water, so you don't have to water your green roofs that often. So that's a potential usage, right? And then beyond the agricultural use, there are a lot of literature out there that talks about functionalizing biochars. So the beauty of that is, we can make biochar in our lab. So we have a lot of control what to add on there. Once you bought that activated carbon, it's made. You just buy it. It's very hard to post-treat all of those things. But biochar, you can pre-treat, you can post-treat. So there's a lot of flexibility, so your professors will have things for you to do, right? You develop functionalize those compounds and to do specific things, to be selective for different applications. For example, acidic biochar may have more advantage in heavy metal absorption. In water treatment, when they test heavy metal absorption, they make their solution, they add acid to make the solution acidic. So, why not just use our biochar, right? And of course, for us, we found that we defatted our biochar first. We extracted fat as biodiesel. So our biochar does not have a lot of tarry material when we made it. And we do find our biochar has more yield than the regular dry spent coffee ground. So in case you worry about what the curves mean, this is what the curves mean,
Did you ever figure out, like Starbucks, how much coffee grounds they make per day or something?
Must be a lot.
Yeah,
We haven't.
There's one right here. I
Mhm,
think
mhm.
you could test, we figure out how many Starbucks there are in the world, how much
Yeah.
you get, because it's probably quite a bit, right?
They give out that for free. So I have a student who used to work in Starbucks, and then we got spent coffee ground from them.
So you can get big bags of it or something?
Yeah. They kind of give you a packet if you want. So that a lot of the time they have it just
I see.
on there. You can just pick them up, get it.
And they don't recycle that or
anything? They usually give it to gardeners.
gardeners.
Yeah.
Oh, I see.
Well, in Japan they do some deep recycling, but not in here.
Yeah.
And then of course this is to show that we made acidic biochar. You see the pH are all kind of less than 7, except the last two, right? And then we measured the function of biochar, FTIR, to see what kind of functional groups they are. And then, biochar applications. I did a very rudimentary growth test that you guys can do as well. And a master thesis from metal removal. And then a master student is working on phosphorus absorption. So for the latter two, you do need to functionalize your biochar a little bit before you can selectively treat the metals or treat the phosphate. You know, the growth test is really straightforward. We just get some Chinese onion. After we cook it, you cut the root part and then plant it back into the pots with biochar. So with biochar, without biochar, and then planted some tomato seeds with biochar, without biochar. And then, of course, I diligently water them every day to get them into here and here, right? And then after, so that summer, I went on vacation for about 2 weeks and gave it to our not very responsible friend. And, you know, her daughter always forgets to water them. And I'm glad when I come back, they are still alive, right? So you can see those onions that they are still alive, and then the one that has the one that has a little sprout that's with biochar, the one without biochar didn't have anything, right? And then we look at the one with and without biochar. The without, you don't see that much of a difference. You know, the one that with biochar, it's kind of slightly better, but not that sure. And then I planted them into the garden, right? It's time to test them. And then the ones that has biochar, so I planted the soil into the garden. The one without biochar didn't survive. And we have, I think our area has not very good soil. It's clay type of soil. So it's not very conducive in growing things, and it didn't survive. And, you know, instead of blaming the irresponsible friend, you know, it reminds me that biochar actually may have some effect in water retention. So the ones that it kind of buffers the plant a little better than without biochar. So at least from this growth test, that's what I learned. Right. And of course, I'm not a good farmer, and I think this needs to have more rigorous tests for the, you know, if we want to move forward with it. And so since Greg and I were talking about biochar application in Africa, because of course agriculture is very important in Africa, and also sustainable agriculture is important. I think a lot of those people, they are still they're practicing sustainable agriculture, and also biochar helps to improve the yield. So after, you know, our discussion, I kind of look into some of the biochar information in Africa. So they do have a lot of biomass and, you know, chicken manure, all kinds of animal manure. So we see some papers on biochar in different areas. So acidic soil is one of the undesirable conditions in some places. You know, the alkaline biochar could help amend that one. And then, you know, we have some applications. And then I think I saw this from the internet that when you have a control, the crop doesn't grow very well. They have this kind of earth is what we call the red earth. It's rich in iron. It's acidic, but it's poor for growing. And then when they have biochar, addition, it grows a little better. When it has biochar and the fertilizer, that's nice. So this is of course just one example. And if you go through the literature, biochar do have mixed results. Some say it helps growth, some say it doesn't. So there is the match of what type of biochar for what plants. At least the acidity is one type of match. And then there are other requirements as well. So we do need to have lab tests and then field tests before we say, we draw any conclusion biochar is good or not. So there's a lot of work out there. I think even the UC gardens, they do some of the biochar work as well, the environmental studies students. So,
Where is that?
they have a test garden somewhere around
On
here.
campus?
It may not be directly on campus, it may be around, I think, or they go to some community gardens
Yeah.
that nearby, they do this.
Yeah. This
Like
our
Terry.
Place over 571.
Oh, oh, okay, oh, probably, yeah, Terry Jacobs
Oh, yeah.
is in charge of those guys.
Yeah.
So we do have some interest in Botswana as well, and especially for the sandy soil, they wanted to keep nutrients and water in there. It's good to add some biochar in there. And of course, in Cincinnati, we have this company it's called Carbon Harvest. They got $400,000 from Bloomberg to build a large biochar facility to process the Cincinnati Park's waste into biochar and make biochar available for people to use as soil enhancement. Hopefully they'll get the reactor built next year and we're going to see it. So the best example is called the Stockholm project, where they did the same thing. They make biochar with the urban yard waste, urban biomass waste, and make biochar, give the biochar to people to reduce carbon footprint. So, yeah. And Stockholm biochar project. So if you Google it, you are able to see it. It's one of the kind of, whenever they talk about biochar, that's what people talk about. And then it's part of the big nature-based solution. So that's, for my research, that's the kind of, those are the people that I collaborated with. So if you want to get hold of me, I'm in environmental engineering, feel free to email and contact me. And well, you're in Rose, right?
Yeah.
I'm in the Mentai Center. So that's where I'm. So that's all I have. Be happy to take any questions. Thank you. Yeah.
So, I had like some previous experience with activated carbon, so I know there was, looking into using coconut shells in place for the activated carbon, like that kind of thing. Is that also, I didn't see it on the list for like the biochar feedstock. Is coconut shell something that's been looked at for biochar, or?
Those things make, those tropical countries rich. So first, initially, activated carbon is mainly from coal. Like in Kentucky, they have a big coal plant. And then those tropical areas, Indonesia, Malaysia, they found coconut shell can make activated carbon as well. So those things, they are higher end of products. So they are not so much considered waste nowadays. Yeah, that's a good point. And sometimes when you buy activated carbon, they may tell you this is from coconut shell, or this is from coal, or from other sources.
Yeah, the waterworks is a huge
Mhm.
plant to make activated carbon for in use to filter.
Yeah.
All the Cincinnati waters down through carbon filters.
Mhm.
So they regenerated themselves at the plant down there. So they have a big tower. It's pretty interesting to see. It's
Mhm.
maybe, I don't know, 8 or 9 stories high. It's a big
Mhm.
kiln. They
Oh, wow, you know
Yeah,
that as well.
pretty interesting.
Oh,
Yeah, we've been down there. We're supposed to do a tour. I'm not sure if we're gonna do it or not. I need to get names, but
oh, okay.
actually it's coming Tuesday.
Oh, we used to take our students there.
Yeah.
So, so
it's
yeah,
interesting.
yeah, if you want to go for it,
Yeah.
well, maybe I'll give you the person's.
No, I
contact.
already have it arranged for next Tuesday.
Oh, oh,
Yeah.
wow,
But if anybody wants to go,
wow,
it's like after this class, like, yeah,
oh, wow,
it's Jeff Boat.
oh,
That's the guy that I know, but
okay, oh, wow, wow.
I'm
Wow.
not sure. It's hard to get people to go, so I don't know.
Seriously, you guys are not going? Wow. So,
It's tricky.
oh, okay, wow.
They have busy schedules.
Oh, maybe, oh, well, it takes more than an hour. So they
Yeah.
have to pretty much,
Jeff talks a lot.
oh.
That's really the tour you could do in about half an hour. If you rush through it. Yeah.
Oh, okay.
But
Oh, but it's
there's a
after
lot of
this.
history. It's one of the
Oh.
oldest.
Yeah, he can go, looks like he's interested.
Right.
Well, I think it's kind of pretty relevant for you guys. Yeah, the environmental people would jump on it, and then maybe some of you will end up working in water or wastewater treatment plants. That is quite a possibility.
Well, a lot of the big, the water quality is really, even just for cooling, right? Like heat exchangers and things. You need to know if you're using a lot of water at your plant, you have to talk to this guy. Be like Cincinnati Water, that's a big part of the operation. Because they deal with the waste water and also the water use.
Mhm.
Usually the big companies, you have to get to be pretty friendly with these people. But they're happy to get more and more water because they're actually a money-making operation. Cincinnati. They encourage people to use water. Not unlike they have the whole Ohio River. It's like they'll give you as much water as you want. You just need to know in advance.
Oh, we don't worry about water, but a lot of other areas in the US, they are worried about
Right.
water scarcity is a big problem.
Yeah.
Like in California,
Right.
it's real.
Yeah. Yeah, it's a funny thing. It's totally different here. If you talk to the people there, they're like, use more. Like you're talking about brown, like a lot of places are using brown water for different, like
Oh, wow.
watering the plants and
Yeah.
stuff. And they're like, no, just use our clean water and pay for it.
Oh, wow.
Yeah, it's pretty crazy.
Yeah, cool.
No, it's really interesting.
Yeah.
For the biochar, if you're using it in an agricultural setting, do you have to do it like every year for the layer down, or is it every 5 years? Or what's the interval for that?
Oh, that's a very good question. I didn't I didn't look into that. So I'm sure if you search in that that's a very good question. And another thing you have to do, I know you have to activate your biochar. You have to, it's the best to mix it with compost before you put it into the field. So like this would be a good time that people prepare their soil. They mix it into the compost and then in the spring apply it to the field. So everything that you mentioned that needs to be done 1 year, 5 years, that's associated with money. So that's, when you talk about acres, that's a lot of cost. Usually it's about 10% volume application. And if that's acres, to do the math.
Other questions? Okay, so thanks for coming.
You're quite welcome. Go to that field trip,
Yeah.
You guys have a class after that? After Tuesday? I think Tuesday are pretty much done, right?
A lot of people's jobs, I mean, I know I took work outside of that.
Whoa, yeah, the students are busier than we do.
Yeah.
My student is like, I can only meet with you at this time.
Right.
You better let me know 3 days ahead of time.
Yeah.
Think about it,
Yeah, I'm down.
Yeah, thanks for coming. That was
Oh, you're
really
quite
interesting.
welcome.
I know you're.
So do we get them on the board? So what do you do with it?
Oh, just,
Oh,
I just shut it down, this thing, I just do that
Oh,
mistake.
okay. Oh, okay. Do we need to log out?
You can,